In these problems, we're doing some work with trigonometric identities. And basically what that means is that one expression with trig functions is the same as another expression with trig functions. And that happens a lot with trig because all of these functions are related to each other in some very interesting ways. Some of these identity problems can be a little tricky, and there are some ways to make them easier. Let's take a look at a couple here. The first one says the expression 7 minus 7 sine x over negative 3 cosine x forms an identity with which of the following. So it means it's the same as one of the following. So we need to sort of manipulate this, change it around, use some facts that we know about trig to try to turn it into one of these other ones. The first thing I would probably do here is try to isolate as much as I can my sines and my cosines from the other stuff going on. So I think what I would do at the top here is factor out a 7. A 7, yeah. And if I do that, I would get 1 minus the sine x. That's something a little bit easier to deal with. So I'm going to do that for 7 times 1 minus sine x. And then that's over negative 3 times the cosine of x. And for the time being, I'm going to think of this as 7 thirds, or negative 7 thirds times 1 minus sine x over cosine x. And I'm just going to work on this chunk right here and put the 7 thirds back in. You can see in the answer choices that the 7 thirds, well, it looks like 3/7 in some cases, but in some form these numbers come back. But let's work on this and see what we can do. I have 1 minus sine x, and I know a trigonometric identity that has to do with 1 minus sine squared x. I know that that equals cosine squared x from the Pythagorean theorem. So if I can turn this 1 minus sine x into a squared, I can maybe substitute something in. So what I'm going to do is multiply it by the conjugate. So we'll multiply the top and the bottom of the fraction by 1 plus sine x. Now what we're going to get here, on the top it's the difference of squares, so I simply get 1 squared, or 1, minus sine squared x. And on the bottom, I multiply this cosine through, I get cosine x plus cosine x sine x. Now on the top, I know this equals cosine squared of x. So, and that is the same as cosine x times cosine x. And now I think I can do some canceling here. So I've got a cosine that I could factor out there. So we'll take 1 cosine from the top and 1 from the bottom. That leaves on the bottom 1 plus sine x and a cosine x on the top. And I think I'm pretty close to one of my answer choices. If I multiply this negative 7 thirds back in, I would get this one, 7 cosine x times over negative 3 times 1 plus sine x. So C is my answer there. All right, let's try another one. This one's a little bit different. We have the cosecant of 2x minus the cotangent of 2x. And it forms an identity with one of these. So you can see the answers here are in much simpler form. So figuring out that identity might make this problem a lot simpler and easier to deal with. So it's a good thing to do. One of the things you should notice is that we have 2 multiplied by our angle here. So we might be using the double angle formulas at some point. But the first thing maybe to work on here is changing these cosecant and cotangent formulas just into sines and cosines. They're a lot easier to deal with that way. So let's try this. The cosecant is 1 over the sine. So the cosecant of 2x would be 1 over sine 2x. And then minus the cotangent is the cosine over the sine. So this would be cosine 2x over sine 2x. What you can see right away is that we have a common denominator here, which is kind of nice. And now we should probably try to apply our double angle formulas and see what we can do. Let me remind you of those. First, we'll start with the bottom. The sine of the double angle is 2 times the sine of that angle, cosine of that angle. So that's going to be our denominator. So we'll have 2 sine x cosine x. And then we've got, well, 1 over that minus, and then on our denominator will be the same there, 2 sine x cosine x. And on top, we've got the cosine. And the trick here is to figure out which one of these would be useful to do. I think I'm going to choose this last one, 1 minus 2 sine squared theta, or u, because the 1's will cancel out, I'll have 1 minus 1. I like that. That simplifies things. So let's try that. Now, I've applied the double angle formulas. So how can we simplify this? Well, first we can do the subtraction. So 1 minus 2 sine squared x is going to be, well, you can think of this as 1 minus 1 is nothing, but then minus a negative 2 sine x. It's going to be a positive 2 sine squared x. And then we'll put that all over the denominator. We've got 2 sine x cosine x. Now, sine squared x is sine x times sine x, so we can cancel out one of those, so I'll erase the squared with this one down here. The 2's cancel, so we simply get sine of x on top and cosine x on the bottom, and lo and behold, that's just the tangent of x. So that one comes out to the tangent of x. So that's a little bit of work with some trigonometric identities.